All right, so now we get into 4.2b. So the second half of 4.2 was all about taking the angle relationships we learned in the first part of 4.2 and applying these relationships in application problems. So let's look at number one. We need to find the measure of angles 1 and 2 given this angle right here. So we need to use our knowledge of the angle relationships in order to determine what angles 2 and 1 can be. Well, so right off the bat, let's look at 100 and angle 1. Okay, so angle 1 and angle 100, we know that they are both interior angles. Okay, they're both inside the parallels. And we also know that they are both on alternate sides of the transversal. Okay, they're not on the same side of the transversal. So 100 and angle 1 are alternate interior angles. So we could say that they are congruent because all alternate interior angles are congruent. Okay, now let's look at angle 100 and angle 2. The 100-degree angle and angle 2, they are vertical angles. Okay, they are two angles that have been created by intersecting lines, and they're basically right across from each other. So vertical angles are also going to be congruent, so angle 2 will also be considered to be 100 degrees as well. And note that there might be different relationships that you could use to justify your answer. For example, what I did here. I said at first that 100 and angle 2 are indeed vertical. And then from there, I said, well, I know that angle 2 and angle 1 are corresponding. And so if angle 1 and angle 2 are corresponding, then that must mean that they're congruent. So if I already determined that angle 2 was 100 degrees, then I know that angle 1 would be 100 degrees. So there may be multiple relationships that pop up in order to help you justify your answer. All right, so for the next couple questions, we've been given this figure up in the top right of lines M and N being intersected by that transversal. So, number 7, suppose that angle 1 right here has a measure of x plus 12. And then suppose that angle 5 has a measure of 3x minus 36. So knowing those two facts, we need to find x. Well, first, let's determine what's the relationship between angles 1 and 5. As we talked about with most of our angle relationships, it's either going to be one of two things. Either they're going to be congruent or they're going to be supplementary, just depending on what the relationship is. So if we look at angle 1 and 5, so they are both on the same side of the transversal, but 1 is in the exterior and 5 is in the interior. So we can't call them same side interior, same side exterior. But if we compare the groups of 4, okay, so we have this group of 4 right here, 1, 2, 3, and 4, the group of 4 angles that are created by the intersection of N and the transversal, and then 5, 6, 7, and 8 created by the transversal and angle M. Well, angle 1 is in the top left of its group. Angle 5 is in the top left of its group. So since these are both in the same position in their groups, then angles 1 and angles 5 are going to be corresponding angles. And corresponding angles are going to be considered congruent. So I can set these two values, x plus 12 and 3x minus 36, equal to one another. So as I do that, I wind up with this. X plus 12 is equal to 3x minus 36. And now I want to solve for x. So I'm going to add 36 to both sides, and I'm going to subtract x from both sides. So I wind up with 48 is equal to 2x divided by 2, and I get that 24 is equal to x. All right, on number 14, once again, we're asked to solve for the value of x using what we know about these two angles. So in this one right here, we're told that lines A and T are meant to be parallel. So if these are my parallel lines, that must mean this is my transversal. So my two angles that I'm given, x plus 20 degrees and x minus 20 degrees. So the arrow that they're signifying is that x plus 20 is here and x minus 20 is here. So right off the bat, we see that they are both on the same side of the transversal and they're both inside the parallel. They're both inside lines A and T. So these are going to be same side interior angles. And same side interior angles are going to be two angles that are supplementary, meaning that if I add them together, their measures will equal 180. So I take these two, x plus 20 plus x minus 20, and set them equal to 180. As I do that, I'm going to combine my like terms. X and x give me 2x. 20 and negative 20 will cancel out, so I'm left with 2x equals 180. And then I solve for x by dividing by 2, and I get x is equal to 90. All right, number 17, still going through and solving for x. So in this time, we're given lines L and M, and they're understood to be parallel. And then in this, we're given two angles. We're given this angle right here, represented with 3x minus 33 degrees, and this angle right here, represented with 2x plus 26 degrees. So, in regards to our transversal, this angle is on top of it, this angle is below it, so these two are on alternate sides of my transversal. These angles are also both in the exterior. They're both outside of the parallels. So combine that together and we get alternate exterior angles. Okay, and recall from our talk the other day, the alternate exterior angles are going to be congruent. So that means these two angles are equal to each other. So if I want to solve for x, I'm just going to take the values that we've set for them and set them equal. So 3x minus 33 is equal to 2x plus 26. So I want to get x alone. So I subtract 2x from both sides. I add 33 to both sides. And I'll wind up getting x is equal to 59.